Hi, and welcome once more to the Allplane podcast. Here talking with the movers and shakers that are redefining the future of commercial aviation. And as usual, before I introduce today's guest, let me remind you can find all the previous episodes of this podcast as well as many other aviation stories on the Allplane website. That's Allplane.tv, Allplane.tv. Today we revisit the topic of advanced air mobility. But we're not going to talk just about any other eVTOL. Jaunt Air Mobility really stands out. Why? Well, because its founders have chosen a rather unique approach to develop their aircraft. Let's first take a step back to about 100 years ago, when a Spanish engineer called Juan de la Cierva invented something called the autogyro, which is a sort of crossover between a fixed-wing aircraft and a helicopter. At the time, the concept didn't stick, but the idea of combining the best attributes of rotorcraft and of fixed-wing aircraft didn't go away. Could actually this hybrid approach be the best way to overcome some of the most pressing challenges that eVTOLs face concerning safety and energy efficiency? Jaunt's founders certainly see it this way and are getting ready to prove it. Jaunt is working on an eVTOL concept that uses both a rotor to take off and land and a wing with 4 electric motors that provide distributed propulsion during the cruise stages of the flight. Jaunt is also thinking about the support ecosystem and the infrastructure that will be necessary to roll out such an aircraft and to operate it efficiently. So it has teamed up with a broad range of partners, and there's even a plan in place to build a whole air mobility network in Quebec, a territory where Jaunt has a big part of its activities. So to talk about all of this in detail and answer my questions about many of the technical and business aspects of the Jaunt project, today we are joined by Simon Briceno, the Chief Commercial Officer at Jaunt Air Mobility. Tune in for a conversation covering in depth some of the most interesting details of a truly innovative project in the field of eVTOL technology. Hello, Simon. How are you?
Excellent. Good to meet you, Mikel.
Thank you very much for joining us today here on the podcast. You are the Chief Commercial Officer of Jaunt Air Mobility, which is one of the most interesting projects in the field of eVTOLs right now, and we're going to soon see why. But first of all, I would like you to tell us a bit more about yourself, your background. I know that you are an aerospace engineer, that you've got 70 plus papers published on aerospace topics. So a pretty impressive CV. Tell us a bit more about yourself, and then we move on to the Jaunt project.
Yes, thanks. And thanks for having me. So I have spent over 25 years in aerospace and aviation. And as you pointed out, the majority of that time I spent at Georgia Tech and as a research faculty in mostly transformative aviation and aircraft design, doing a lot of conceptual design, developing advanced design methods as well for novel aircraft configurations. I spent a lot of time looking at the integration of technologies like electric motors and batteries, developing distributed electric propulsion architectures, and exploring how that allowed designers to come up with very novel configuration designs and provide better performance and better capabilities for different markets. Worked very closely with NASA, particularly NASA Langley, the FAA, and the FAA Research Center in looking at the safety aspects as well for a lot of these different configurations.
Actually, the safety aspect, I think it's a very important component of the project you're working on now, Jaunt, because of the very peculiar configuration of your engines and the different structural elements, I would say, right?
Absolutely. In fact, we can go a little deeper on our design. But yes, we have the 3 key I would say benefits or highlights of our aircraft are the safety, the efficiency, and the acoustics. Mm-hmm. And that's something, all 3 of them are a result of the aircraft design itself, the patented technologies that we have. And I can certainly explain why we believe we are the safest aircraft, eVTOL, in the market, and why we're the most efficient. And those are, obviously very two key factors for not just certification, but to have a viable, economically viable operation for our customers.
We can talk about all this in a minute, but first of all, apologies because I interrupted you.
No.
You were explaining how you had studied in depth all the matter of safety. Please continue because
absolutely. And so I spent at Georgia Tech over the last decade or so before joining Jaunt, doing research closely with those organizations, looking at these different configurations, understanding their pros and cons, right? It's not always just about performance. There is obviously a very key safety factor. There's a lot of acoustics. We know that, aircraft for this market flying at low altitudes near large urban areas, a big factor is public acceptance, and probably number one on their list is the noise that a lot of existing rotorcraft like helicopters have. And so I did that. I also had a lab that I managed for unmanned aerial systems, particularly looking at smaller drones and prototyping, looking at the development of autonomous capabilities, path planning, all these different new technologies and capabilities that will eventually find their way onto larger aircraft like the one that we have at Jaunt. We're currently, certifying a piloted aircraft, but eventually over time, as autonomy becomes more and more common, we will introduce, some of those capabilities into our aircraft. So that was the sort of the high level of the research that I did over the last decade or so at Georgia Tech. And then I joined Jaunt over 2 years ago. Jaunt is a relatively young company too. It's 3 years old. I was part of the working closely with the founders before I joined, and I did my sort of own internal analysis, and there were many factors why I decided to join Jaunt. But of course, the two that stood out to me was the team itself, and I can share, particularly our CEO and his experience, but the rest of the team as well, and their background and the knowledge that they brought, and the aircraft, the business model, the aircraft that we have, the technology and the approach that we're taking to commercialize our aircraft, not just to develop a platform for testing and experimentation, but truly to get to a quick commercial vehicle that we can field to our operators. And so those, there were other factors as well, but it was a pretty straightforward decision to come on board. And my role at Jaunt now is to focus on doing a business development, commercial strategy, managing all of our different customer relationships, and also looking at beyond the aircraft. When we are going to bring this aircraft into the market, there's a new ecosystem that will have to be addressed in terms of infrastructure, and particularly charging infrastructure. As I mentioned, the public acceptance, there's quite a bit of education and awareness that needs to be brought to the public. And so that's kind of the role that I play at Jaunt, and so that kind of an overview of my background.
Excellent. I think it would be great if we could then move on to the aircraft, because the aircraft, I must say, I'm going to post some pictures on the show notes, but it's something truly unique in this eVTOL space. It reminds me a little bit, there was, I think in the 1920s, 1930s, there was a Spanish engineer called De la Cierva that he created a concept. It was, I think he called him an autogiro, which was a sort of a mix, a crossover between a fixed-wing aircraft and a helicopter. And your concept is a little bit similar in this regard. Obviously, the technology is a lot more modern, but you have an aircraft for 4 passengers that combines a fixed wing with distributed propulsion. So it's got 4 small engines on the wing, but it also has a central propeller on the top, like a helicopter. So it looks a bit like a hybrid when you see it from the outside. And that, I guess, has some advantages. Maybe it has some cons as well. Why this concept, and what are the advantages that brought you to this structural solution?
Yeah, absolutely. I'll start by saying that for decades in aviation, fixed wing and rotorcraft aircraft designs have proven to be, the safest and most efficient designs for horizontal and vertical flight. So in other words, all the fixed wing aircraft that you see today pretty much look the same, right? It's a kind of a tube and wing. They're the most efficient aircraft for cruise flight. And for vertical flight, helicopters primarily, having a single main rotor has been the most efficient, and it's really all just about physics. Helicopters look the way they look because they're extremely efficient in vertical flight, but helicopters, unfortunately, are not efficient at all in cruise flight. And what we wanted to do is to combine the best of both worlds, essentially take the most efficient in both of the flight phases. But it really wasn't until what we call, the age of electrification in the last decade or so that really has allowed us to take those two sort of concepts, bring them into one. And it's what you call a compound configuration because it has both of the fixed wing and the single main rotor. And now with the advances in battery technology and electric motor and motor controllers, we can truly take advantage of the efficiencies of both of these. But there's still one missing element, and that's our patented technology. We acquired the slowed rotor compound technology from a company called Carter Aviation that had been developing this slowed rotor compound design for several decades. And their concept was an autogyro. They were able to develop a prototype that has over 300 flight hours and mature the main rotor technology. What we did is we took that technology that now is part of Jaunt, and particularly on the main rotor design, and we combined it with an all-electric aircraft, and we added electric motors to the main rotor. And so what that means is we are not an autogyro. We're not a gyro. We are a fully hovering, powered lift aircraft. In other words, we operate like a conventional helicopter in vertical flight. But then with that technology, and that's why it's called slowed rotor, once we transition into cruise flight and we offload the main rotor, the weight of the aircraft is now on the wings, we can slow that main rotor down significantly. And this has been something that's been very difficult to achieve for many reasons. There's a lot of instabilities and vibration effects with main rotors. But we get down to less than 100 RPM. And in the prototype that we have that has been flown in the past, when you are underneath and you look at it fly and with the wings only, that main rotor is spinning so slowly you can actually count the number of revolutions with your naked eye. Wow. And so what that means for us is not only are we taking advantage of the fixed wing efficiency in cruise flight, but our main rotor is offloaded. It's just going along for the ride. Think of it like a flywheel, essentially. It's just spinning. It's effectively auto-rotating just in cruise flight. Okay. And then as soon as we get to our destination and we need to transition back to vertical flight, our electric motors spool the main rotor back up, and we land like a conventional helicopter. Mm-hmm. And so that effectively, it's a very simple design. Simple is good because engineering wise, it means that we don't have many moving parts. We have a very straightforward design from a certification standpoint and a safety standpoint. It's also very advantageous. And so, yeah, our 4 propellers on the wing. We have 2 electric motors on each wing. They provide the anti-torque for the main rotor. So if you think of a conventional helicopter, it has a tail rotor. The function of a tail rotor is to prevent the helicopter from spinning on its axis because of the torque from the main rotor. We don't have a tail rotor. Our tail rotor is effectively the propellers on our wings, and that's how we provide that anti-torque.
Mm-hmm.
And we have much more redundancy than a conventional helicopter as well.
So basically, to visualize it, you would take off and land vertically with the main rotor. And when you are cruising, basically the four engines on the wings do most of the work. The main rotor is still spinning. Is it still consuming some energy, or it's spinning just because of the movement through the air makes the rotor spin a little bit?
Right. The reason it's actually still spinning is because part of that patented technology is the design of that main rotor. In other words, it has tip weights on the tip of the rotor, some heavy weights. And so when we take off vertically and we spool that main rotor up like a conventional helicopter, there's energy that's stored in that. Think of it again like a flywheel that has a weight. And so that main rotor is provided in cruise flight. It's slowed down and it continues to spin because of some of that energy that's stored in that rotor, but it is providing the electric motors are providing very little energy just to keep it spinning because it needs to spin from a stability standpoint. We can't completely stop it. But 95% of the weight of the aircraft is on the wings, and the aircraft in cruise flight is operating like a conventional airplane. It has the wing-mounted propellers that are providing the thrust. It also has conventional flight control surfaces, so it has ailerons, elevator, rudder, and so the pilot flies the airplane flies the aircraft like an airplane. But yes, the rotor continues to spin just naturally with a little bit of power, but also because of those weights on the tips of the rotor.
And could it land as a conventional fixed-wing aircraft if needed?
It can. It absolutely can do that on a runway. In an event of an emergency, for some reason something happens to the main rotor, we can land. But the beauty of the safety is that we can auto-rotate and use our fixed wing, the combination of both. Unlike a helicopter, and of course, unlike a conventional airplane that only has one of those, we have both, but we also have enhanced auto-rotation capabilities. So unlike a helicopter, if some of you or your audience familiar with the height velocity diagram or the dead man's curve in helicopters, there's a region, two regions where, helicopters cannot auto-rotate based on the height or the velocity or the combination of both. And of course, helicopters require some significant forward velocity when they auto-rotate. In other words, when they come into land, they're actually moving forward and they end up doing a very drastic flare in order to land safely in auto-rotation.
The auto-rotation, is it what happens in case of a mechanical failure in a helicopter? Is the safety mode of landing or...
That's correct. So in the event of a power failure, a loss of an engine, for instance, on a helicopter, the helicopter won't just fall to the ground, right? It has the energy that's already in the main rotor, as well as the forward flight of that helicopter. The pilot can pitch down the helicopter and use the airflow coming up under the main rotor and change the pitch of the main rotor to actually provide slow down the helicopter, essentially. That's the auto rotation. And so what we would do in our aircraft is the same procedure, but because we have more energy in that main rotor, we can come down slower and more vertically. In other words, we have the ability, and of course we have the use of our fixed wing for additional lift. And because our aircraft is fully controlled by computers, the pilots, the combination of both is completely automated. And so the aircraft can land vertically from any altitude. It could be 5 feet in a complete loss of power. And this is a big differentiator for us from other players in this market that have multi-rotors. In the event of a loss of all multi-rotors in a lot of these designs, you find yourself in a much more, difficult situation because you really at that point depend on the very small wing that you have. And of course, if you're over a city or urban area, you're not going to have a runway, most likely. So you have to depend on other technologies like parachutes, and it really complicates, the safety. And so we're very proud of the simplicity of our design and the use of just the physics and the energy in the rotor to land safely in the event of a complete power loss, which if you look at the statistically and the reliability of these systems, like commercial aviation today, the chances of that are so low, but you obviously want to be prepared for it.
What about the drag? Does it create a lot of drag when you're flying horizontally? The rotor,
yeah. It does not, and the reason for that, and as the comment I made about the helicopters are extremely inefficient in cruise flight because they don't have a wing, and they rely on their main rotor spinning still pretty fast to provide that lift in cruise, and that main rotor is what causes that drag for helicopters. What we have been able to do by slowing the rotor down is significantly drop what we call the drag, and therefore increase the lift over drag ratio, which is an important measure of the efficiency of the aircraft. And we've been able to do that because now the weight of the aircraft's on the wing produces very low drag. It's what we call a high aspect ratio wing. It's very similar to a glider. If you know sailplanes or gliders, they're designed with very long wings, but that are very have a short chord, and for that reason they can stay flying for a long time. And our wing is very similar. It's a very high aspect ratio wing because we only need it in horizontal flight. We have no flaps, because we don't plan to take off and land from runways, so we don't need to generate the lift on our wing at those flight phases. We just need it for cruise.
And recently, actually last month, there was some announcement that the FAA was considering changing the certification process for eVTOL from Part 23 that applies to small aircraft to the certification that applies usually to tilt rotor aircraft, which, well, yours is not a tilt rotor, but I guess it has some elements in common with tilt rotors because you need to coordinate all these different engines, that the ones that make you fly horizontally, the ones that power you for the vertical lift. So what's your take on this? Is this something that could potentially benefit you if this change goes ahead because of the characteristics of your concept?
Yeah, so my understanding so far is that the change is proceeding from the FAA. But to answer your question, no, it does not affect us. And the reason for that is, again, another differentiator with us and some of the other applicants for certification that are pursuing Part 23. We are not pursuing Part 23, we are pursuing Part 29. And Part 29 is a transport category for rotorcraft. It's a type certification. And the reason we can do that is because our aircraft configuration is considered a rotorcraft by design.
So a helicopter.
Correct. A helicopter is a rotorcraft, and the way that the FAA and other certifying authorities they define the category of rotorcraft. Helicopter is one, autogyro is another. So there's other types of rotorcraft, but the important thing is is the fact that we can lay out a certification basis that primarily uses rules from Part 29. And then of course we have a fixed wing, so we're going to have some rules of the fixed wing category in Part 23. So the answer there is that we laid out from day one a certification path that was very clear, very straightforward, with rules that existing, with means of compliance that exist. So we'll have some special conditions, of course. We have a battery on board, and but yes, we're very confident that our certification path is not going to be affected by this new announcement.
You mentioned the battery. What type of battery are you planning to use? Because that's 100% electric, right? Battery powered.
Yeah, that's correct. We are working with tier one suppliers, and our battery energy management supplier is BAE Systems. They have an amazing track record in developing electrified systems, and they are designing and our battery system, as well as the flight control computers, fly-by-wire system that we have on the aircraft. And we are all electric, and there's certainly a lot of benefits for that. But they're working very closely as well with Crane Aerospace, another tier supplier that is going to provide a lot of the electrical system to the aircraft.
What about the materials? Because I think you are also, that's another area where I think you are using some innovative technology. That's, I think, thermoplastics, right, in the structure, which is a bit different from composites, from what I understand. It's a different type of plastic-like material, right?
It absolutely is. And again, another difference for us. We truly believe that this technology is critical for the mass production of these aircraft. So thermoplastics, it's a plastic. It's not a thermoset like a composite that requires, as you know, composites have take a lot of labor to manufacture. And when you're thinking of mass producing, thousands of these aircraft a year, you have to rely on a technology that can be manufactured a lot quicker. And so thermoplastics itself can be hot press formed. It can be welded together through induction welding technologies. We're working with Carbon Aerospace to provide a lot of that technology and capability. And that's going to allow us to develop our primary airframe structure in thermoplastics and allow us to essentially just bolt the aircraft together at certain places without having to go through any rivets, any kind of manual labor to assemble the aircraft, which is extremely time consuming, certainly doesn't help to sort of optimize the production.
Why are these thermoplastics not more widely used instead of composites in the industry?
Yeah,
I mean, in general.
Great question. And in fact, Airbus and Boeing have already started to explore the use of thermoplastics. It's a very novel technology for aerospace, certainly when it comes down to developing the technology to connect and to sort of combine thermoplastics together. As I mentioned, the induction welding, it's still being developed, and that is part of the analysis that we did in terms of the sort of the risk reward. Is there's still some R&D that is going to take place, that it currently is taking place with our suppliers on that technology. The maturity, though, is increasing pretty rapidly, and we will see all of aerospace, manufacturers, OEMs use thermoplastics going forward. We don't know when, but it's a much more versatile product than composites for the reasons I mentioned. Things like maintenance as well. When you get a puncture in a composite, it takes a long time to repair. Thermoplastics can be repaired a lot quicker as well. So for many reasons, it's a better product, but it does require some of these, manufacturing processes to be developed, and they are still being developed. For our plan and our sort of timeline, it fits very well.
You have already been racking up some orders, right, for your aircraft? I don't have the exact number here, but I think something in the region of 175 plus orders at the moment.
That's correct.
From whom? I mean, I read recently you have signed an agreement with a company called Vertico in Quebec, right? I mean, first of all, let me just say something we didn't mention. You are your main base is in Montreal, right? But you also have operations in the US.
Correct. Yeah, I can expand on that. The company our company Jaunt Air Mobility is headquartered in Dallas, Texas.
Okay.
We have a small team there, and our business plan, our aircraft development plan, primarily, yes, it has a very strong ties to Canada, to Quebec in particular, and the reason for that. And so yes, we'll have final assembly in Montreal. The reason for that is because we are certifying with Transport Canada. Again, a differentiator for us, the FAA, Transport Canada, and EASA all have bilateral agreements in that if you certify with one, you can validate with the other two, and you essentially have, type certification with all three. Transport Canada has tremendous amount of experience and expertise, particularly in the rotorcraft certification. They have certified all of Bell's helicopters since 1982. And that's very critical for us because the group that will be doing, the certification testing at Transport Canada needs to have that rotorcraft experience, which they do. And so for that reason, we have decided to take our, final assembly primarily in just outside Montreal, which is where actually Bell Helicopter is doing their final assembly and certification as well. And I didn't mention this, but I want to just say a quick word about our CEO and his experience. Martin Perrier has held various executive positions at Bell Helicopter for 30 years and Triumph Aerospace Structures as well. And he spent several years in Canada overseeing the development and certification of helicopter programs, Bell's helicopter, with the Transport Canada. So that experience is instrumental, not just with the certification agency, but also with the supply base in Quebec. As you know, Quebec is the aerospace industry in Quebec is very strong. They have Bombardier there. They have, other key tier one suppliers, CAE, that is a flight simulation company that is partnering with Jaunt to do all of our pilot training. Yeah. All of that is critical to us. And so bringing our manufacturing and production there was a very important move for us. We also have the support of the government in that they are looking to bring environmentally friendly aviation, electric. There's a lot of electric transportation companies there. And so there was a lot of support, and that's going to, again, give us a more clear path to getting through our program. Mm-hmm. I think you asked about if you want to switch, I guess, to the customers, or do you want to talk more about Quebec?
No. Well, that's definitely a very interesting topic. I've been in Montreal. I've been visiting Bombardier. I've seen some of the facilities where they do all the fittings for the executive jets, which was very, very interesting. Oh, yeah. So yeah, it's definitely a very, very dynamic aerospace cluster. I think also like some eVTOL, I think this Dufour company from Switzerland also announced recently they are moving some operations there.
That's right.
To take advantage of all this ecosystem. But actually related to this Quebec thing, I wanted to ask you about this agreement that you recently announced with this company called Vertico. I don't know if I pronounced it correctly.
Vertico. It's correct. Vertico.
Yeah, to develop a network a regional mobility network with your aircraft in the whole of Quebec, basically. Your aircraft has a range of between 80 and 120 miles, can fly in about 175 miles per hour. So I think the idea is actually to connect many rural communities to larger urban centers, right? Because it's an area with large distances, a very sparsely populated area. So I guess that's where you come into play. What's this agreement about, and how you plan to get involved in this? Are you going to operate this aircraft yourself, or is it going to be Vertico that is going to operate them? How does it work?
Yeah, that's correct. It's Vertico. Our entire business model is about selling aircraft to operators, existing and future that have found, obviously an opportunity with urban air mobility or advanced air mobility. Vertico is one of them. They've got a lot of connections on the infrastructure side, and they've developed a network, an initial, day one sort of operation for using these electric aircraft to move people in and around Montreal, but also, as you pointed out, to connect certain communities. Canada and Quebec, it's a lot of land, a lot of traveling on the ground, and there's an opportunity to sort of save time with these type of aircraft. And so the partnership that we have with them is to begin to explore, how we can help them with our aircraft in terms of its performance, where they can start their type of operations. What are some of the key routes that they've been analyzing that they can see, demand for this type of aircraft. And so there's still a lot of work to do in identifying a lot of those and laying out, a plan to either leverage existing airport infrastructure, maybe develop potentially down the road some new vertiport infrastructure. But that's the plan. And of course, Montreal is the starting point, but there's other cities, obviously going down to Toronto and other areas in Canada that would benefit tremendously from bringing a VTOL aircraft, certainly an electric VTOL. We do have a hybrid concept that we've been sort of working with a supplier called Vertigo Aero out of Florida. They have a hybrid propulsion system that is extremely beneficial to combine it with the design of our aircraft. But our primary aircraft program is the all electric, and as battery technology improves, our range and payload capabilities are going to improve. But Canada does have, whether it's remote, indigenous regions that could benefit from bringing cargo, medical supplies, things of that nature. There's a lot of use cases where these eVTOL aircraft could benefit. And Vertical Mobility is a company that, is initially exploring the use of passenger or the use of these aircraft for passengers.
You've got this plan to roll out in Canada, but you've got orders from other potential operators, right? From other prospective operators. Have they been disclosed, or that's still kind of under wraps?
Yeah, the three that we've publicly disclosed are Vertical Mobility, as you pointed out, the most recent in Canada, and then we have a company that's currently operating over 900 different aircraft. They're in Brazil, and their name is Flapper. Flapper has both fixed-wing aircraft and rotorcraft, like helicopters. They're definitely very forward-looking in modernizing their fleets and working with new electric aircraft. And so we did sign a letter of intent with them to bring our type of aircraft to not just Brazil but Latin American cities that could definitely benefit from moving people quicker and more efficiently through in and around the urban areas.
Interesting that actually Latin America is one of the largest markets for rotorcraft at the moment. It's one of I think Sao Paulo has the largest fleet of helicopters anywhere out in the world.
That's right. And, they have, in particular in Sao Paulo, they've got tremendous congestion, traffic, and there's a lot of value in moving people. And of course, not everyone can afford a helicopter ticket. And that's where, the use of these electric technologies can drastically reduce the operating costs for operators. In our case, we're reducing over close to 50% of the direct operating costs for an operator. And that really translates into a much more affordable ticket price for the average. And it's only going to get better with higher utilization. And so, there will be other sort of hurdles, challenges to overcome, managing the airspace with many more of these, and certainly providing more infrastructure in different locations. But there's already an opportunity once these aircraft get certified to replace, very inefficient, expensive, and certainly noisy helicopters. And so Sao Paulo one, there are a lot of Latin American cities and around the world, Asia as well.
What sort of numbers are we talking about here? What could be the typical urban fare for an eVTOL ride on a Jaunt aircraft?
Yeah, so the way we like to sort of frame, the cost to a passenger, if you look at the metric we use is dollars per passenger mile. So we have at the day one sort of outset of these operations, we can see, a passenger paying, between $4 and $5 per passenger mile. So if you look at a 20 mile distance, you're looking at $40. If I'm doing the math correctly, I'm probably not, but it's it's definitely much more affordable than, a conventional helicopter. And then progressively, as I said, as we increase the utilization of these aircraft and provide more routes, these operators will be able to reduce that price down to $1 to $2 per passenger mile. And you're starting to now get into the area of competing with, your ride sharing options on the ground like Uber and Lyft. And so it's a very attractive opportunity because you can move people. You are giving them another option, and it'll take some time, but it's certainly a step change relative to what's available today.
One of the things that might be a bit of a barrier, maybe it's the infrastructure. And I think on this front, you are also active because I think you have created a subsidiary called Access Skyways, which, correct me if I'm wrong, but from what I read on the website, you work together with a number of partners to make sure that this infrastructure is in place. So how much involvement you have with all these, let's say, the vertiports, charging stations, and, well, basically the whole ecosystem that is necessary for air mobility to take off?
Yeah, we believe that we're primarily an aircraft development company. That's what we do, and that's our mission. However, because the aircraft is not just a conventional aircraft, fuel-based, it is all electric, and there are some novelties to the aircraft operation itself that. And certainly in the types of new markets that will emerge, there's a need to address some critical aspects of the ecosystem, and we can't leave that until right before we operate these aircraft. It has to be done now, certainly with regard to infrastructure, and in particular charging infrastructure, and helping our customers and operators really develop an operational model that is viable. And so what we decided to do, given that, of course, we were very knowledgeable about our own aircraft, but also understanding of what's required in terms of power and energy requirements, we decided to bring together, as we have with our approach to developing our aircraft, we bring together the people who know these areas best. And so we formed this group. It's a branch of Jaunt. It's called Access Skyways, that is really bringing experts around the table to address some of these difficult and challenging, aspects. And so we're working with BAE Systems, who is our primary supplier for the battery management system of the aircraft. They also have a lot of development technology on the charging side, and have developed capabilities and technologies that will minimize the disruption to the grid on day one. And that's important because, again, it's a factor that will affect the public. And so we want to be able to minimize that disruption. But they have a lot of expertise in that area. And so they're in this group. We're working closely with a company called Avports. They manage airports here in the U.S. They have over, I believe, close to 10 or 11 regional airports that they manage, and they have a lot of experience understanding the operators, the operations of both helicopters and fixed wing, and they're forward looking as well, and wanting to be critical, wanting to be a key player in the future market and provide not just services from a airport standpoint in some of these key cities, but also help to solve and address some of the infrastructure challenges that will be needed for these operations. And another company that's working closely with us on Access Skyways is a engineering and architecture design firm called PS&S. They worked closely with Uber Elevate, who, as you know, were the initial group in sort of bringing together this potential market opportunity, and they did a lot of analysis and engineering studies in developing and rendering vertiport designs for the future. And so, of course, a lot of their designs that they've been helping us with are much more futuristic. And when we have more scaled operations, they've been able to design and develop, an approach to the infrastructure that's sort of more that can be scaled. In other words, they have a solution for a day one vertiport versus a year 5, year 10 vertiport that is more of a verti hub and a verti stop. And you can imagine there's going to be varying sizes and considerations. And so those three and a couple others are we're working closely to really try to say, okay, how are we going to address some of these ecosystem challenges? The aircraft is one piece of this puzzle, but we can't assume that everything else is going to be addressed on its own.
Do you have a date or an approximate date for the start of operations? Well, actually, for the first flight, you've been flying a small-scale demonstrator, right, already?
Correct. As I alluded to earlier, we acquired the technology, the slowed rotor compound technology from a company called Car Aviation, and they did develop a piloted prototype to mature. We call it a technology platform. It's the Jaunt technology platform. Has 300 flight hours, 10,000, 1,000 takeoff and landing. Sorry, and so that has flown and matured the main rotor, and the main rotor is one of the most critical design aspects of this aircraft, of any aircraft. And so we now have moved on into our design phase and engineering development. And we plan to have a flying demonstrator, which in fact is really a pre-production model, since our design is very much fixed in the sense of, we will have some tweaks to go through, but that demonstrator will be flying in hopefully in 2023. That's our goal.
Wow, that's early, yeah. That's already around the corner.
That's right. And we're working. Fortunately, our suppliers are making excellent progress. And then, we'll go through a certification program through Part 29 that will have at most, four other aircraft to go through testing and development. And we plan to have type certified aircraft by 2026. And at that point, prior to that, of course, we have negotiated agreements with our customers and plan to have them soon thereafter operate their aircraft.
2026 would be, in theory, if everything goes according to plan, it should be ready for commercial operations.
Correct. Entry into service. At that point, the aircraft has been certified, airworthiness certification, and our customers, of course, have their operational certification, and so they can put the aircraft into service.
And in the meantime, where can people find out more about Jaunt? You have the website, Jaunt Air Mobility, all in one word.com, I think. Any other channels, resources you can recommend?
I would say, we obviously are very active on social media, particularly on LinkedIn. Please follow us, follow our company there. We regularly put, articles about our partnerships. We're going through a pretty exciting phase right now in the process of raising capital. I want to mention, of course, that we are now an aero company, in that we merged earlier this year with 5 other aerospace and defense companies to form a group called Aero. And we are looking forward to sharing a lot more of that. This is as much as I could say now, but we're very excited about our future and the synergies we have with some of these companies, which will help us as well in our program. But so really hope your audience can definitely take a look at our company and more and what we have to offer.
Definitely. Does this group have its own website?
It does. It's currently under development in that there is a website. It's called theaerogroup.com, and by Aero, it's spelled AIRO, and it's theaerogroup.com. We are a wholly owned subsidiary of that group. The website is going to be changing, but there is an overview of the companies and the target markets that we're doing with that group. But of course, that doesn't impact our plans with Jaunt. Everything I shared with you stays the same. It gives us actually more opportunities.
Excellent. I'm going to be adding this to the show notes then. Well, Simon, thank you so much for your time today and for this very interesting chat. Wishing you all the best with this project. And definitely everyone listening, just go check it out. It's a very unique concept, and it would be interesting to see it flying soon, because 2026 is not that far into the future, actually.
That's right. No, thank you. It was a great pleasure talking with you, Michele, and very excited about this new world of mobility and air mobility. I hope, yeah, your viewers and listeners rather can get a chance to learn more about it.
Mm-hmm. Thank you very much, Simon. Bye.
Thank you. Bye-bye.
Before you go, and if you like this podcast, a quick reminder that it would be absolutely great if you could please give it a rating on Apple, Spotify, or whichever platform you're using, or recommend it to a friend or whomever might be interested. Thank you very much and see you soon.